Hello, welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In the last video, we started talking about loops. In particular, we looked at the while loop, and we started with the while loop because of its simplicity. The while loop basically takes a condition which evaluates to a Boolean, and as long as that Boolean expression happens to be true, it keeps going. It's really hard to get much simpler than the while loop as far as the conceptual side of things. However, that doesn't necessarily mean the while loop is the easiest to use in programs, and for that reason the while loop is not the loop that is used most commonly by programmers in many different languages, including Scala. The loop that is actually probably used most commonly in most languages is the for loop. And so in this video, we want to go over the basics of the for loop. Scala's for loop is actually very powerful, so we're going to have two videos covering the different aspects of the for loop. But we want to start with just the basic things. So let's go into Scala, and we'll start off doing an example very much like what we did with the while loop. I want to count to 10. Okay, and let's recall what that would look like. So we would need to put something inside of the while loop, and in order for this to work, the first thing that we have to do is declare a variable. I'm just going to call it I, and I'm going to start at 1. So I want to go count from 1 to 10. Normally we will wind up counting from 0, but here I'll just count from 1 to 10. And then I can have my while loop while I is less than or equal to 10. I want to do two things. First, I want to print out I, and second, I need to increment I by 1. And if we run that, we count to 10. Okay, so this is counting to 10 with the while loop, and like I said, the simplicity here is just it's while and then some condition, and this stuff just keeps repeating over and over again as long as that condition is true. Now let's do the same thing inside of a for loop. So we use the keyword for, and we open with parentheses, which is the common syntax for these control structures, whether it was the if or the while or the for, or other things that we will see. And inside of here, now what goes inside of here is not just a simple expression. Okay? In fact, there are lots of options that can go inside of here. But for the basic form, it's going to have kind of two parts. The first part is a pattern. And of course, the simplest pattern is just a variable name, like I. And then this arrow, and this arrow points to the left, and it's typically read as in. So we read this as for I in. And if I want to count to 10, I will say 1 to 10. And then inside of here, what am I doing? Well, I'm printing out I. Now, the thing about the for loop in Scala is that it is actually what in most languages would be called a for each loop. Technically, the for loop in Scala runs through a collection of things. And we can see this if we, for example, create a list of some different values. Okay. And then I can run through those elements just to show I can use a different variable name. Here I'll say v. It's the value that I am pulling from the list. So this should be read as for all v's in the list. What do I want to do? I don't know, how about I just print v squared, so it's not just a simple value of v. And we get 9, 25, 4, 64, 36, and 1. These squares are the values that are in that. Okay, so this shows you in some ways why loops in this book are covered after the collections. That's actually not very standard for a lot of programming languages, but in the case of Scala, really it's helpful to understand lists and arrays before you can talk about your for loop, and because the lists and arrays are so powerful, you can do a lot with them without having while loops or for loops or whatnot. This begs the question, what was going on up here? What does this 1 to 10 mean? Well, because we're in the REPL, we can actually type in 1 to 10 and see what that gives us back. 1 to 10 creates something called a range. Okay? A range is another sequence type, just like the array and the list. It's a somewhat more restricted sequence type in that it's evenly spaced values. The normal range happens to be integer values. And so you can see it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in there. So now what is this really? Well, it turns out that the method, this is calling the to method on 1. So we could have written this as 1, 2, 10. We get the exact same result. However, here we use the operator notation. You might recall from earlier on that if you do something like 4 plus 5 in Scala, that's actually 4 plus and a 5. I put the space here because otherwise, well, I think Scala gets confused. Well, okay, yeah, it gets confused because it thinks that it's a double because of the 4 dot there. Putting the space, we get an integer value. Remember that plus, minus, multiply, divide, modulo, the normal operators are actually just method calls, and you can invoke them like methods, but no one would ever do this. We always go with the operator notation on these. You could invoke to using the normal method call syntax, but it's much simpler to type it in just using an operator syntax. And the operator syntax can work with things that aren't symbolic operators. Any method that takes 1 or 0 arguments can be called leaving off the dot. So now it should make sense to you why this loop right here worked and did what it did. The 1 to 10 produces a range object which has the values 1 through 10, and each value is put into I one after another, and we print them out. Okay, so that's what's the most basic use of a for loop. Some other details of range. What if I wanted to count down? Okay, what if I wanted to say, for example, well, I want I in 10 to 1. Well, turns out that won't print anything, okay? Because by default the range is counting by 1. At least your integer range by default counts up by 1s. So if you want to count down, we have to tell it to take a different step. And we can do this very simply. There's a method called by on the range. And if I wanted to count down, I tell it to count by -1. And I would get that. If I wanted it to only print the even numbers, I could have it count down by -2. Had I gone from 1 to 10 and I only wanted the odd values, I could say by 2 and get that. You can also make ranges of other types. So the char type has has a to method which will give you a range. Notice this isn't a normal range, this is now a numeric range. Like I said, the basic range only supports ints. For chars, we get something that is slightly different. If you want every other letter, you can tell it to go by 2. One thing that's worth noting here is if you do this for doubles, turns out that just using 2 doesn't quite fully specify things. Whereas for integral values like the int or the char, or short or long or byte, just using 2 will say, okay, I'm going to create a range and the stepping is 1. It counts by 1. If you do this with doubles, there is no default stepping. It doesn't really make sense to have one. So instead, you have to specify. So if you wanted to count by 1s, you can say that. Of course, the thing about being doubles is that you could very easily just be counting by 0.1 or 0.2 or 0.5, whatever. If you're watching closely, you might wonder, why are all these digits here? Go back to chapter 3 and remember the fact that doubles are not perfectly precise, and it turns out that 0.1 is a repeating binary number, which is why we don't represent money with doubles normally. Okay, so that is the use of a for loop. We saw it with ranges. We did it with a list. You could do it with arrays. Whatever you want. The for loop will pull things from collections and run through them. The use of the for loop so far. So let's go back up here to one of our for loops. Sure, and I'll just go back to the basic form. Here I use the for loop as a statement, not as an expression. So remember the distinction here, an expression is something that has a value. This for loop did not give me back any value. It only had side effects. It printed things for me. The while loop worked this way. The while loop only had side effects. It cannot be used as an expression. It is only a statement. In the case of the for loop, though, I can use the for loop as an expression. And if I want to do that, I include the keyword yield. So right after I close the parentheses on the for, I say yield, and then I can put whatever I want. If I want it to be, if it's going to be long, I can put curly braces, because remember, set of curly braces really is just like a single expression where the value is the last statement in it. Let's say I just wanted, we'll go back with the square idea. I just want to print, or to get back the squares of these values. And you can see here that it gave us back a collection which has the squares. The collection it gave us back is called a vector. Now, don't let this confuse you or intimidate you. A vector is basically kind of a cross between an array and a list. It works very much like an array, with the except that it's immutable. Because our collections are, or because our ranges are collections, the sequences. Turns out all the methods that you've gotten used to using. Let's give this a name. Val r equals 1 to 10. The methods that you're used to using, like for example map. If I wanted twice the value of all those numbers, I can map to underscore times 2, and you'll notice that we get this back. While a range went into the map, a vector came out. And the reason is because, of course, when we map things, we can come up with things that are not simple ranges. So the range gives you back a vector instead. Had I wanted to go with my square function, I could do a map something like this. And so, choosing between that, and actually if I really want to go closer to what I have in my for loop, choosing between this syntax and this syntax is really a matter of style. If you like to use the for loop, you can. If you like to use the map function, you can. And it's kind of up to you and the style that you choose. A lot of times when we're counting, we do count from zeros, because as we saw, for example, the indexes in an array or in a list or in most other things in Scala start at the value of 0. And so, for example, if I wanted to do the indexes of an array that has 10 different values in it, I could say 0 to 9. Turns out that because this is so common, in addition to 2, there is an until. And what until does is it simply is exclusive on the high end. Okay, so 0 to 9 or 0 until 10 give you the same result. Why would you want to do this? Well, for reasons like this. So if I replace this with a 2, and in fact we can do that, this crashes, okay, because I can't go up to the length. The highest index that we have is the length -1, and so you could say -1, but instead it's customary to use the until, which excludes the top value. So 2 goes all the way up to the top value, until doesn't. Okay, we've seen simple uses of for loops, both as statements when we don't get back a value and as expressions where we do get back a value. And what I'd like to do with this real fast is to play with a little bit of data, because these were kind of just playing little games. I would like to actually write a little bit of a script here. And I want to have the script read in, no, let's not use VI, let's use less. a CSV file. Now this CSV file happens to come from the Bureau of Economic Analysis, the BEA. BEA has lots of different data files in here that you can look through. I'm pulling up the personal income data, and I pulled it up from 1950 to 2011. And I chose to do a download and download it as a CSV file. So we've played with CSV files before. This one's going to be a little bit more complex than some of the others, which could potentially cause problems if with our simple method of splitting stuff. It won't in this case because of what I'm going to read. But if you want to find some interesting data to look through, the BEA.gov is another source of cool data. So this is what that data file happens to look like. It has some top lines up here that give you header information. So first line, second line, third line, and fourth line are just kind of headers, and I would like to skip those to throw them out. The next line is what year you're looking at, and the line after that is the personal income, and there's a whole bunch of other stuff after this which we could read in and do stuff with. I actually just want to play with these two lines, the year and the personal income here. So first off, because I'm going to do this with input redirection, I'm going to send the whole file in. The first thing I need to do is I need to skip the first 4 lines. Now we could just say read line and copy and paste and do that 4 times. Hey, we've just learned how to nicely do a for loop. So it's very easy for us to say, hey, for 1 to 4, read line. Might be good to put in a comment saying what we're doing there. Why are we reading in 4 lines and pretty much ignoring them? Now, the next thing that we want to do here is we're going to read off this years. So year strings equals read line. So that's going to get this entire line right there. And that line happens to, so it's comma separated. It's fairly nicely behaved. Where we would run into problems with doing our splits would be a line like this. Notice this has 2 commas embedded inside of a single entry. That would cause us problems if we cared about that line. Fortunately, we don't. So we can simply split the line that we care about on commas, and that will be sufficient for our needs. And then I'm going to do one other thing. I'm going to drop 2. Why am I dropping 2? Well, because I don't care about that or that. I only care about the stuff that starts at 1950 here and goes up to 2011. So what does this give us back? So first, actually, let's go ahead and print that out in the name of showing you what gets messed up here. Oops, sorry. I do need to do the input redirection. So we skip the top lines. We read in 1 line, we split it on commas, and I drop the first 2, and then I printed it. And it looks like this. Okay. The reason for this is because the arrays in Scala wind up using arrays in Java, and arrays don't print nicely. So if I want this to be in a format that we can actually read, I'll call mkstring, and I'll put these back together with commas. And now if we run the program, you can see that we have all of our years. But I really don't want these as just years in this format. I would like to mainly because I don't want the quotes. I want just ints. Okay, this is a bunch of strings. What we have here, this is an array of string. I don't want an array of string. I want an array of int. So what I'm going to do is I'm going to make years. Now I could do this with a map, and in fact, last chapter we would have done this with a map. However, we've just learned about for, so I want to pull out the y from year strings, And because this is on the right side of an equals, I know this has to give me back a value, so I am going to yield a value. Now what do I want to yield here? Well, I want the integer for one of these. And I can't just say toInt, because there are quotes there. That won't work. So I somehow need to get rid of the quotes. How could I do that? Well, one way would be to call substring and take the substring from 1, so this would be index 0, 1, 2, 3, 4, and then go to 5 because the upper bound is exclusive. So that would be one way of doing this. I guess we could also do a remove on the quote. Let's play with that one. Remove all. Now, what happened in here was interesting. Let's make sure that's actually correct, and at least it compiles. The Java string doesn't have a. How about we do a replace all? That'll work. Okay, so I'm going to replace the quotes with nothings. You might look at this and wonder, what is going on here? What is this? Well, this is that problem that I have where I want to represent a double quote, but if I just put that, well, this isn't so happy. If you want to represent a double quote inside of double quotes, at any point, you need to put a backslash in there. The alternative is to use the raw strings, which are which have triple double quotes. In this case, because all that we have is a single double quote, I went with putting in a backslash. So that gives us back the years, and we can verify that that worked. By actually printing out the year values, and so there we go. I would also like to do basically the same thing with the next line in the file, and this is the income line. Now the income line doesn't have double quotes around it, so it's actually going to be easier to work with, and so I will do this on one line using a map. I'm going to take that read line. I am going to split it on commas. I'm going to drop the first two, and then I am going to map it to double. Okay. And to verify that we have that, put a comma instead of a period. There we go. Okay, so so we've pulled out all of the income values, and now the question is, well, what to do with this? What could I make or do calculations on? Simple things to do might be to pair things up. And now how could we do this? Well, a simple way to do this would be to just take years and zip it with income. Another thing that's interesting to do is to take the difference from one year to the next. Okay, so the year-over-year difference inside of here. How might we do that? Actually, let's calculate this in two different ways. Called diff1. One way is going to be to use a for loop that goes through the indices. So I want to do for I in, and there are two ways of writing out okay, so 0 until how about income dot length minus 1. Now you might wonder about this, why the until prevented me from doing a minus 1 earlier, but if you're going to take the difference between 2 years, so if I'm going to take the difference between the income sub I and the income sub I plus 1, I have to start not on the last value. I have to stop not here, but I have to stop here because I'm looking at the next thing in line. So I need both an until and a -1 here. And then what I want to yield is income sub I plus 1 minus income sub I. And if we run that, we can see what the year-over-year change in income and personal income has been since 1950. It's just because it's worth doing so. Instead of printing those with comma separate, if I wanted to print each one on its own line, different way of doing this would be to say diff1 for each print line. Let's save that and run. It's also interesting to note that because the for each takes a single argument, we can do this using operator notation. Make sure I save. Okay. So diff1 for each print line prints out all the elements. Just to show how it works, let's take a different approach to doing this diff. Instead of running through indices here, I want it to do this in a different way, and I'm actually going to utilize the pattern matching here. So I am going to put in a pattern. I1 and I2, the income of one year and the income of the next year, in, and when we've seen patterns in the past, one of the first places we saw patterns was in a val so we could pull apart tuples. That's exactly what I'm doing here, and this is one of the great things about the for loop in Scala is that you can just put this pattern directly in. Now, here I want, so the first element is supposed to be an element from income. The second element is supposed to also be an element from income, but it's supposed to be from the next element.